Hello everyone, hope you can hear me fine. And today we'll talk about, as said by Alex, an introduction into the JavaScript Elasticsearch client. So a little bit about myself. I'm Thomas Della Vedova. I'm a senior software engineer here at Elastic. I work in the clients team and work mainly on everything JavaScript related. And I also maintain the Elasticsearch JavaScript client. So let's start with this. Interacting with Elasticsearch is very simple. You can just use a curl, send a request, and get back the response. That's it. Which means that you can easily use your favorite HTTP request library in Node for sending a request and getting back the response. So there's not really the need for the client, isn't it? So we'll see a little bit more about that. A question you can ask yourself is, cool, so we are working with HTTP, which means that I can easily use it from the browser, isn't it? Well, let's say that this is what any developer has said before a data breach. So as a very, very good rule of thumb, never expose Elasticsearch to the rest of the internet. Because will you ever expose your database, your MongoDB instance, your Postgres, Redis, and so on to the internet? It's better not. So you should always have an application in the middle between your users and Elasticsearch. It might be a complex application, a simple Node.js proxy, anything is fine, really. So this is how you normally see an application with Node and Elasticsearch. You have your application, which uses the client that connects to Elasticsearch. It's very easy. But more likely, behind the scenes, what's really happening is like this. So the client is connecting to a multitude of nodes, depending on the architecture that you have and how big is the cluster of Elasticsearch. And this is because Elasticsearch is a distributed system that scales horizontally. A node is a single instance of Elasticsearch, and a cluster is a collection of nodes. So what the clients, all of them, not just the JavaScript one, are doing for you, given what you just said? Well, they offer an automatic node sniffing that you have to enable that allows us to know the system topology. And once we know the system topology of Elasticsearch, we can start load balancing the requests so we avoid the overloading of a single node, which is very, very useful for keeping your cluster healthy, even if Elasticsearch is already doing a lot of smart things behind the scenes to avoid this situation. Then, as soon as we notice that a node is no longer reachable for any reason, for example, a network issue or the node has crashed, then the client has a fail fast and automatic retry to the next available node. So let's go a little bit more precise about JavaScript and know more about what all the clients are doing for you. So we can start by saying that Elasticsearch loves JavaScript. And the reason is because JSON. Everything works in JSON with Elasticsearch, which JavaScript, as you know, really loves. So how do you get the client? Well, it's available on NPM. You can install it with npm install @elastic/Elasticsearch. If you search for Elasticsearch on NPM, you will find the two packages, @elastic/Elasticsearch, and another one called just Elasticsearch, which is the legacy client that we decided to deprecate in favor of this new one. We do support Node.js 8 and above, but please use at least Node.js 12, because in the next months we will deprecate the support for Node.js 8 and 10 as soon as 10 goes in EOL. You can find the source code on GitHub at elastic/elasticsearch-js, and the documentation on the Elastic website with ela.st/js-client. So how the versioning works with the client, but really also with the rest of the Elastic stack. So we are using semantic versioning, which works in this way. There are three numbers: measure, minor, and patch. And every time we increase the measure, it means that there is a breaking change that you may need to handle. Every time we increase the minor, there is a new feature that you very likely enjoy. And finally, if we increase the patch, it means that very likely we have fixed a bug. So a good thing to do is always keep your client up to date. So a good question you can ask me is, okay, which version of the client should I use based on the Elasticsearch version that I have? So for answering this question, we came up with an extremely complex math formula, like any math formula really, which can really be simplified in this way. You are using Elasticsearch 7.10, then use the client 7.10. The client follows the exact same versioning of the Elastic Stack. This is as easy as that. So just forget about this formula. But it was fun to write it. So how does the client work? This is not always needed for you, but as soon as you need to do something more complex or advanced, this knowledge becomes very, very handy. So this is the client architecture on a, let's say, high level, which is also valid, by the way, for other clients. So we have the API surface. The client supports all the APIs of Elasticsearch, so more than 230 APIs. And every time you call an API, internally the client will call the transport, which basically is the coordinator of the request. The transport will take care about serializing, parsing, running sniffing operation if needed, prepare all the headers, collect the body response. And for sending a request, the transport will ask to do the connection pool for a valid connection. A connection on the Node.js side is nothing more than bare-bone HTTP client with a keep alive agent. But what we mean with connection is basically the representation of a node to Elasticsearch. So if you, for example, configure the client to use sniffing and we know there are 10 nodes, we will have 10 connections in our connection pool. So what the connection pool is? The connection pool is nothing more than a class which contains what we call an alive pool that have all the connections that we think they are still reachable. As soon as the transport needs to send a request, it calls the selector, and the selector picks one of the connections. It gives it to the transport runs the connection, and if the connection has been successful, it will mark it as alive and put it back in the alive pool. Otherwise, if we call the mark dead API, the connection will be moved to what we call the dead pool, which is not a Marvel character, but it is a smaller separate pool that we use for retrying connection over time to figure out if they are still dead or they are back on track. In this case, we just move them again into the alive pool. So how do you connect to Elasticsearch with the client? It's very easy, really. You just require the client, and also be aware that both ES modules and the TypeScript are supported as well. So whatever is your taste, we got it. Then you have to create a new instance of the client, and you can pass the URL of the node you need to connect to. You can even pass us multiple nodes in case you already know the addresses of the other nodes. A very, very important topic that I'll stress a lot this evening is authentication. So please always use authentications, because usually you should protect your Elasticsearch instance with your infrastructure, but it's always better to be safe and also enable authentication in your cluster. So how to use authentication with the client? Well, you have different ways. The one is to pass the basic authentication credentials in the URL, as you can see on line 6 here. Remember that if you are passing the credential URL, you also need to URL encode them. Otherwise, you might have some issue. For solving this URL encoding problem, we also offer an authentication option, which accepts either a username and password for basic authentication, or an API key, which we highly, highly recommend to use. The API key can be either a base 64 encoded key, or the parameters for creating the key that Elasticsearch is giving you back as soon as you create a new key from Kibana. You can also configure a custom SSL configuration if you have some very specific need by just using the SSL option, where you can pass a custom certificate, reject unauthorized request, and so on and so forth. If you don't want to care about connection pooling, other authentication issues, certificates, and other issues like along these lines, what you should do is really use Elastic Cloud. The client offers first-class support for Elastic Cloud. The way it works is very easy, as you can see here. On line 3, we are declaring a cloud key instead of node, which is an object that contains an ID. The cloud ID is a string that you get as soon as you create a new cluster on Elasticsearch Cloud, on Elastic Cloud. Then you should pass your base authentication or API key credentials, and you're good to go. So how do you use the client? How the client works for all the normal use cases? Well, let's start with this. The client do not want to enforce you a way to write the code. So we are supporting both callback API and promises API. The way we pick which one to use is based on if you are passing to the client a callback or not. So if you do, you are using the callback API. If you're not, you will get back a promise. So it's completely transparent for you. Then, as you can see here, from line 8 to 11, we are calling an any client method with the promise API. On line 9, there is the first option object you can pass to the API, which is everything that will get passed to Elasticsearch. While the second object on line 10 is are all the options that are client-specific that are needed for having some additional configuration for your request. What any API method returns you? It returns what we call a result, but you can really call it in the way you like, which is an object that contains 5 keys. The body, which can be either an object, for example, for a search response, or a Boolean for any header request. So if you want to check, for example, if a document exists with client.exist, the body will not be an object, but a Boolean value. Then the status code of the operation, the headers, the warnings, if there are, and a metadata object, which basically tells you everything you might need to know about the request. So what was the request, what was the response, status code, how many times it was retried, if it was aborted, and so on and so forth. As I was saying, it really tries not to enforce anything on you. So it really tries to solve most of the problem. But there are cases where it might have a very, very specific need you need to address. So for solving this, the client can be easily extended. So let's get back again to the client architecture. Everything you are seeing here, aside from the client API, so transport, connection pool, connection, the serializer, can be swapped with your own implementation. How that works? With the JavaScript client, you can, other than exporting just the client, we are exporting the class constructor of each one of the classes you saw before. So serializer, connection pool, and transport. In this example, let's say that we know the shape of the object that we will index to Elasticsearch for the entire lifetime of our application. So we want to speed up the performance. How we can do that? We can, speed up the serialization performance, which is something that can be done with the library fast JSON stringify. The way it works is that you pass a JSON schema to it, you create a custom serializer function, and then on line 14, you basically create your own serializer class, which extends the base one, and you override the method you want to change. In this case, the serialize method. Then on line 23, we are passing the custom serializer class to the client constructor, and finally we can use the client normally. Another interesting topic I wanted to mention about is child clients. So let's say you have the situation where you need to have a slightly different configuration based on the request that just came to your application. So some must be executed with an admin user, some with a normal user, others with a read-only users. So how can you solve this? The easier thing to do is to use a different client based on the situation. But these have a not really nice drawback, which is each client will need to create a new TCP connection for every time you use it, which is a quite big waste of resources. So what the client is offering to you for addressing this issue? Child clients. Child clients works in this way. Here, line 3, we are creating a normal client with the usual configuration, and then you are just using it. Let's say that later on you get a new request which will use the normal user client instead of the admin one. As you can see here on line 11, we are calling client.child, which will return you a child client that then you can use, which is the same as the parent one, but it has a different authentication credential. The nice thing about this is that the child client shares the connection pool between all the parents and the other childs, which means that there is no need to create a new TCP connection each time. Everything gets reused. A very important topic I wanted to mention is client observability. If you already use the client, you may have noticed that there is no integrated logger. So if you want to know what's really happening behind the scenes, you need to use the client observability APIs that we offer. I can say there is not really a logger. There is a debug logger, but it's not really, it should not be used in production. It's just something very useful for development. So how can you understand what's happening in the client? You should use the events. The client is an event emitter, which at the moment is exposing 4 different events: request, response, sniff, and resurrect. Sniff and resurrect are not really needed in case you are working with Elastic Cloud, because those problems are automatically solved for you. So let's focus on request and response. A request gets emitted every time the client sends a request. Be aware that if a request gets retried, you will see multiple request events for the same API call. Then you will see the response event. Any event has the exact same signature, which is, as you can see here on line 14. The first parameter is a possible error, while the second one is all the metadata we have gathered while preparing or receiving this API request. So the first thing you may need in the metadata is the request ID. Each request gets automatically associated with a request ID, which by default is an integer, which, as you can imagine, is not really useful, as every time you create a new client or reboot the application, this ID is not really unique. So what you should do is either pass the custom generate request ID function, as you can see here on line 6, which is an asynchronous function which takes the parameters and the option of the request and generate an ID accordingly, which then you can read, as you can see here on line 13, with a result.meta.request.id. Or if you already have the ID from something else, from the context, and it depends by how your application is instrumented, you can directly pass it to the API option, custom options, as you can see here on line 20. In this way, the ID will be propagated to in the all events, and you can then log it easily. In other cases, you may not need to use the ID of the request, but you need to have some additional metadata for any reason. So the way you do this is, as you can see again on line 20, there is this context key, which can really be anything: an object, a Boolean value, a number, a string. You can pass whatever you want there, and you will find it again in the metadata in each event. You can also pass, as you can see here on line 5, a global context that will be merged with the local context if defined. And this also applies for if you're using child clients, for instance. You can pass a different context based on the child client you are using. Another extremely important topic which I want you to focus about is the Opaque ID. Opaque ID is a very, very useful feature of Elasticsearch, which allows you to understand what's not going really well with your application and the way you're using the client and Elasticsearch. Let's say you have some warnings that you don't know where they're coming from, or a search request which is very slow every now and then. The way you solve this is by configuring the Opaque ID in the client and then just use it. And later on, by looking at the logs of Elasticsearch, namely the deprecation logs, the audit logs, and the searches logs, you will find the same Opaque ID, so you can connect it to your application to understand what's going on. The way you use the Opaque ID is very simple and straightforward. On line 9 here, we are passing the Opaque ID key to the API configuration. And remember to give a very meaningful name, so you really know what that Opaque ID in the logs, what it does mean. You can also, as you can see here on line 6, pass an Opaque ID prefix, which is something that will be added to every other Opaque ID if configured. In this case, it makes sense to add the host name of your machine dash the meaningful name you have chosen for your API call. The last topic I want to talk about is client helpers. As I was saying before, the client supports more than 230 APIs, and there are some of those which are extremely powerful, but often are not easy to use for different reasons. So for example, the bulk API is extremely useful, but then you need to understand if some document have failed, how to retry them, how you can parallelize multiple bulk operations. It's not that easy writing that logic in your code. So the client offers you an easy way for doing this with the bulk helper. The way you use it is just, as usual, create a new client instance, and then on line 10 here, you do client.helpers.bulk. This will return you a bulk helper instance, which will reserve to a promise, and we will see in a moment what it does. Let's focus on the options that the bulk helper accepts. Everything you're seeing here, aside from data source and on document, are not required. It's everything here so you can know what it does, but you really need to add just the data source and the on document callback. So the data source usually is a readable string. So it's something you have, let's say you have a data set on disk you want to ingest, you just create a read stream from it, you pass it to the data source, and you're good to go. The on document callback, which I was saying is a required parameter, is a callback that gets called every time there is a new document that needs to be indexed. So if we have a new line delimited JSON, it will be called for any line. And then you should return back what you should do with that specific document. In this case, we want to index the entire dataset in the demo index. Then we have an on-drop callback, which gets called every time a document cannot be indexed. And it will be called after the document has already been retried the numbers time you have configured. Then we have flash bytes, which by default should be around 5 megabytes, which basically is how many documents the bulk helper should collect before to send the actual request. Then we have the flash interval, which is how much time the bulk helper should wait if we don't reach the flash bytes, but you still want to send all the data. Concurrency, which as you can imagine is how many operations we want to run at the same time, how much time a single document should be retried, how much time we should wait for a document to be retried. And finally, on line 23, we have the refresh on completion key, which is very useful if you're indexing data, because if you can configure it to either true or the index name. And as soon as the bulk helper finishes, it will refresh the index so the data is available as soon as possible. As I was saying, the bulk helper returns a promise. The promise will resolve to a statistics object, which gives you an overview of everything that has happened. So how many documents you have indexed, how many bytes you have sent, if the operation has been aborted or not, how many documents failed, and so on and so forth. You can also use the bulk helper with async generators, which is very, very interesting. Here on line 7, we are defining an async generator for a very, very simple case. Obviously, you will need use async generators for more complex cases. Here we have a data set, and we are yielding each document of the data set. Then we pass the generator in the data source, and we are good to go. It's as easy as that. There are cases where you may need to index data on demand. So you do not have all the data on disk, but you are reading it from Kafka, for example, or from other resources. So what you should do in that case? Well, the easiest thing to do is to create, as you can see here on the left, an utility function. Let's call it stream indexer, which takes the client and the index name where you want to add all the data. Inside of it, you should create a readable stream, which is what the client needs, the bulk helper needs for indexing the data, with object mode true. Then create a new instance of the bulk helper, pass it the data source, configure the on-document callback, prepare to catch any errors that might happen, and return back an object with 2 methods, index, which is the method you will call for adding data, and stop if you indexed everything you needed to index. How you use this, you can see here on the right, you create the new instance of the stream indexer, you pass the client, the index name, and then on line 10 and 11, you can call this index method each time you have a document. And finally, as soon as it's finished, on line 13, you can call stop and wait for the bulk operation to resolve and get all the statistics. Another helper the client offers is the multi-search helper. And the reason is it's not because multi-search is a difficult to use API, is quite straightforward, but it's because there are some cases where your application can be under a lot of stress. It could perform a lot of search requests. So for solving this issue, which namely is if you send a lot of search requests per second, you need to create many sockets, putting under pressure both your Node.js instance and Elasticsearch. So what the multi-search helper does is creating basically a sink where you throw inside all your normal search requests and send them in batches. In this way, given that you are under heavy load, the performance will be mostly the same, but the number of sockets open will be way lower. You don't need to pass any option to the multi-search helper, but these are the options you can configure. You can say how many operations you want to send per multi-search request. What is the flush interval if you didn't reach the maximum number of operations? The concurrency, again, retries and wait. Similar to the bulk helper. The way you use it is just to call m.search, which returns a promise, where you pass the index, where to run the search, and the query you need to pass. Be aware that this API, other than returning you the body, status code, and so on, it also adds a documents getter, which give you directly all the documents that has been returned from the request. Last but not least, the scroll search. Scroll search is another very useful API you can find yourself using. The problem with scroll search is that it's not that easy to use in Elasticsearch because you need to paginate the results, you need to remember to clean the scroll at the end. There are a lot of edge cases you need to cover. So the best way for using it is really use the scroll search helper. The way it works is that you pass the normal scroll search configuration, but then for reading the result, you just use a for a wait loop and gather all the results. That's it. You don't need to do anything more. As soon as the scroll finishes, the helper will clean the scroll, so it will also free up resources into Elasticsearch and clean up the memory in your application. So, where you should ask if you have any kind of question or a bug. First of all, if you have a feature request or a bug, please open a GitHub issue in the client repository. And if you have an issue that is not a bug, you can either again open an issue in the GitHub repository or open a new question on Stack Overflow by using the Elasticsearch and JavaScript tags, or you can use our discuss.elastic.co forum, or also reach me out on Twitter at Delvedor. If you have some kind of a discussion, great idea, or if you build something really cool that you think we should check it out, please drop me an email at thomas.delavedova@elastic.co. And so with this, I would like to thank you for your attention and wish you a great evening or day, depends on your time zone, and I'm here if you have any questions.
Yeah, thanks a ton, Thomas. Let me see. I didn't see any questions in the chat, but I can just open the participants to also unmute themselves. So I just did that. If you have questions, feel free to ask. I have two things that I actually noted down. And the first one is about versioning. You explicitly mentioned that you need the 7x client and to talk to a 7x version. There are two things. First, I think we should probably talk about compatibility, just to make sure that you don't have to update everything at the same time. I think it's just important to mention how this works, like forward or backward. And the other thing is there may be deviations in the version if you need to release more patch releases, right? I just want to make sure that this is fine if you use it, because this might be confusing if you say we just have to have the same version.
Yeah, that's true. So about the versioning, you should really follow at least major and minor. Obviously, if you are using Elasticsearch 7.10, you can easily use the client 7.2. The difference is that you will not have all the new features. And so we do recommend to have the exact same version if you really need to have all the latest features. About the bug fixes, the client at the moment can release fixes outside of the release cycle of Elastic Stack, but this might change in the future. So we probably end up aligning also with bug fixes with the rest of the stack. And sorry, what was the other question?
Yeah, I think that pretty much sums it up. Like the one described the forward compatibility, the other one described like the patch release and the possibility of having different versions which are still like working well with each other. I think that's just the important point.
Yes.
And so you're also
not forced to. The rule of thumb is inside the same measure, you are good to go.
Yeah, I think that's a great rule to have. All right, Antonio has a question in the chat. Is there any repository with some examples using this JavaScript client so people can get up and running quickly, or maybe just show the documentation and do a screen share so people know where to look for things?
Sure thing. So let me screen share again. So there are some examples in the JavaScript client repository. You can either go to docs and open the examples folder. And inside here, you will see different examples for very specific APIs. You can also see them on the online documentation at ela.st/js/client. See here the examples, the very last topic. If you open it, there are different examples. So for example, how to use the exist request. And there is no complete example with an entire application yet. We are thinking about it, but it's not yet, because as you might know, the Node community, there are a lot of opinions on how an application should be built. So we don't want to give too much opinions in the examples. So for now, we ended up with showing very, very specific examples you can easily copy and paste and run. Thank you for the
question. Thank you. I think there's an additional question. Is there a repository with example, none like one that is exposed as an API? I suppose, maybe just correct me, Antonio, if I'm wrong. Are you referring to something like Open API, Swagger kind of things, which just lists the kind of available API calls to the endpoints, or is it something else you're after? Because maybe one thing you could show, Thomas, would be the JSON test classes and the YAML test and the JSON API definition. Maybe that's something that other people could use to figure out what kind of calls are available.
Well, so the way we create the client, there is let me do a step back. We have, the Elasticsearch has a JSON specification, which contains all the APIs that are supported, and we use it for generating the clients. So you can either go into the Elasticsearch repository and look at this, but probably the easiest thing to do if you're using the JavaScript client is to open the JavaScript client documentation. There is a reference doc, which contains all the APIs supported by the client with a very, very small example and a link to the documentation of the specific methods.
Did that answer your question, Antonio? Is there anything you would like to know further about that?
Okay, no, there is not yet an application that uses the client that we can show, but thank you for the feedback. We can definitely do something more on that side. What you would like to see in this case? A simple search, or maybe a more complex fuzzy search? How to do, for example, having a Kafka input for doing a lot of ingestion? What you would like to see in a complete application example?
Yeah,
because the problem I normally have with application is you have to show a lot of stuff to making it work. So you have to assume people knows, for example, the framework you're using. You have to decide if you want to have authentication or not. If you don't, you have to write everywhere, please use authentication, a normal example. So there's a lot of overhead, which I'm not sure I would like to throw on the users.
I mean, maybe do you know any open source applications making heavy use of the client? I mean, the biggest one obviously is Kibana here, like that's the elephant in the room regarding client usage. But maybe there's a kind of a common Node.js based tool that people are aware of, where they just know they can take a look at that and see how that one is using the client.
So I'm not aware of any open source application. There definitely are some around because the client have a lot of downloads and it's being used in a lot of places on GitHub. You can see how to use, for example, the bulk helper in the different logging libraries of Node, all the logging libraries that has a transport option. So for example, Pino or Wisdom and so on, they are using the Elasticsearch client with the bulk helper for reading the data from the standard output and sending it to Elasticsearch later on.
Yeah, it probably also makes sense to take a look at every kind of tool that writes data to different data things. Like one of the things I remember has an Elasticsearch output is Node-RED, for example, these small tools to manage IoT devices. I think that's a good start as well, because I think that one is bulking requests as well before sending them over to Elasticsearch. All right, if you have further questions, just go ahead. I do have one as a time filler, so if anyone has a question, just put them in the chat. I saw you mentioned the bulk helper, and me coming from the fancy enterprise Java world, I do remember that the bulk helper in the Java client also works on the document count. I didn't see that in the options. It was only a flush interval and the size. Was it on purpose?
Yes, it was on purpose because when we were designing it's a good question, first of all, because we discussed a lot about this when we were designing the bulk helper. The reason why we ended up with the flush bytes is that the first implementation had the document count. But the problem about document count is that you never really know the document size. So there might be the case where you are sending, for example, 1,000 documents that are very, very small, or 1,000 documents that are very, very big. So if you always know the size in advance, this can be easily fixed. But if the document size changes a lot during time, this could be a problem. And so for solving this, we picked the solution of using the flush bytes, which addresses both the issues. And also for solving the subsequent problem, which is what happens if we do not reach the flush bytes, we have added the flush interval, which enters every time we are waiting too much before to index the data. So for example, if you want to be very, very sure that all the data is indexed, you have to configure a low flush interval value, which by default, I think is around 30 seconds. So for example, all the loggers, shippers normally have a way, way lower value.
Yeah, thank you. And I think one of the questions that's always interesting for anyone following a talk is like, what's next, right? Is there any big things coming up, changing the structure of the client, making something more accessible, better, faster? I think you recently did something a lot more faster with less memory overhead, but also just in big things like anything potentially breaking backwards compatibility, rewriting it in Deno. I have no idea, like just go ahead. What are the big things coming up?
So I will say there are two big things coming up in the future. So let's start with a safe harbor statement. We are working very hard on this, and we are trying to do it as quickly as possible, but we want to take time to be sure that we get it right. So the two major things we are going to do is a complete rewrite of the TypeScript definitions of the client, which means that, so basically the problem at the moment is that the client is fully typed, but what is not typed is the different request bodies and response bodies parameter you can send and receive from Elasticsearch, which is not ideal. So we are working for fixing this. But as you can imagine, having 238 APIs to support, It's a lot of work to define all this. So we are working for having a full type definition that will be shipped soon. That it should not be a breaking change, but it might cause some problem to users because for any reason, because usually TypeScript is very, very annoying about complaining about your code. And sorry about my opinions here. And but the way we are designing this is that you can easily override our definition or take some time to adapt to our definition. Because the way we want this to work is that if something is not working for you, we want you to open an issue in the client so we can address it very quickly and fix it for everyone else. And the next step, about as soon as we have the full type definition for both requests, bodies, and responses, is to have a complete DSL library for search requests. So something that helps you actually building queries and so on. Which I can show it to you right now, but I'm very happy about how it's taking shape. And both of these will be released and very likely in the 7 release line. But both of those will be released as a beta because we want to take some space if we need to address some design issue that we didn't foresee while creating the functionality.
Yeah, thank you for that answer. I think that helps a little bit, especially like keeping things in better is usually a good idea. And I mean, this sounds like it's an addition, so it should not be kind of breaking anyway, right?
No, it should not. The only breaking change that might happen in the future is that we are planning to drop the support for Node.js version 8, which is still supported at the moment, but has been EOL'd since 2019. So please do not use it because there are no more security fixes for it. AWS Lambda is no longer supporting it, so we'll do it very soon as well. And unfortunately, we have to drop the support for Node 8 in a minor release instead of a major, as you normally do in the Node.js ecosystems, because we need to follow the exact same version of the stack. So if you are on Node.js version 8 or 10 in the future, you will start seeing a warning log in your application telling you, hey, be attention that this will be the last supported version of the client or maybe the next one. And if this case applies, what you should do is to lock your dependency to the minor, so you're sure that you will not have any breaking change with the next versions. But hopefully, everyone should be on the latest LTS releases of Node, so this should not apply to you.
Yes, for sure. Everyone is always on the latest releases. I would never worry about that. Thomas, do you have any kind of final words? Unless there's another question that you would just have with us, like regarding the client, any fancy things, anything that everyone should know, but you totally forgot to mention?
It's a good question. Well, let's say that I tried to keep the presentation short with definitely the most interesting features, but the client is really offering a lot of other stuff, which I didn't have time to talk about. So there are also other smaller, let's say, not less important, but less with more focused case helpers that you can use. And there are also many other options you can configure, from the sniffing if you need to use it. And if you do, there is a blog post in the Elastic blog, which I highly recommend you to read, which tells you when and how and if you should use sniffing at all. And let's see, I think you should be it. Read the code. This is the best recommendation I can give to anyone. Always read the code of the libraries you're using, not just because, not just the client one, but any library you're really using in Node, because it's very important knowing what's happening in your application. And it's also fun about learning something new.
Absolutely. I usually start with reading the tests, so you also know if there are any. I think that's usually a great start for any library. If they're not, just skip the whole library.
If there are no tests, it's not a library I will trust. I'm very proud about the 100% code coverage of the client.
See, that was the kind of sneaky info I was expecting. Very good. All right, we don't have any other questions, so all I can say is basically Thank you for everyone coming by, for listening, asking questions. Thanks a ton to Thomas for presenting, preparing everything, and running it here. I will put up everything online in the next couple of days as soon as I basically recutted the video, so we just end up with the important parts in there. And yeah, with that said, have a good day, have a good evening, everyone, and hopefully see you the next time.